Hello friends, my name is Sovan Samui. I I hope all are good in health. So let's start. In this video, content is will be shown the final assignment and foundation analyze and design. Okay, so foundation analyze and design. How to foundation design and analyze is must be checked as a software SF6 2016. Okay, so first we have some required data in this foundation, and this data is this. Okay, this is the our project. This is the building foundation. This foundation we will be design. Okay, this is the C column 1, column 2, column 3, column 4, like 16. Okay, so this foundation will be some consideration is the safe bearing capacity 300 Newton per meter square, and allowable settlement is the 1 centimeter. Okay, then this column 1, column 2 up to 16, this data will be generated in the ETABS softwares, and this dimension also have given, and data also given, and line also given. So this data we was generated the ETAB software, but um, this data will be generated from there, and we have to replicate in the SAP software, I mean foundation software. First we are open the software. Okay, so this is the software. Okay, first we are going to the first model, and then go to the IS code IS456, and go to the units, and have to unit the matrix details. Okay, matrix default, and then use the designing preference is the minimum coverness is the 50 50, and this is the 22 river bar. So this is the 50, this is the 50. Then okay, then this type of grid system we have selected, and we have a foundation, and the total length is the 80 meters, and this is the 80 meters. So 80 meters, 80 meters, x direction in the 80 meters, and y direction also 80 meters. So grid we are required the 19 and spacing we have to consider 1 meter. So we have the grid system is required the 19, and y grid also required the 19. Then okay, then grid system also generated, and this grid system also generated. Okay, then then we are define the material. Okay, define the material, add a new material, and we are using the M40 grade concrete. So this is also M40 grade. This is the M40 grade concrete, and after M40 grade concrete material type also selected the material get also selected the concrete. Okay, then the weight per unit per volume is the 25, we are given kilo by meter cube, and this also given 31622.7, and this also is came from the ice code. Okay, this is the 0.000055. Okay, then this is we are using the M40 grade concrete, that is the compressive FCK is M40. Okay, material have to be done, and we have one more material. This is the name is the HYSD, high yield strength deform 500. Then is the river, and this data is the 77, and elastia model is to 2 into 10 to the power 5. Okay, this is the 500, this is the 4 500 545, sorry. Okay, then okay, material have to be done. Then up to going to the slab property. In the slab property, add a new properties is the slab one. We have to the name of the slab is the name is the mat foundation. We are giving the name is the mat foundation, using the material type and go to the, and in the thickness we are given the 500. Then okay, then okay, after slab properties, going to the column properties, add a new column properties. Column 1 we are select the material is the M40, and column is we have a two type of column is the 500 one column, and one have a 600. So we are giving the 500, and we have a one more type of column, so this name is the column 2, and we are select the material M40, and this is the 600 okay, we have a two type of column right now. This is the 500 and is the 200. 200 into 200 and 600 into 600, sorry, 600 into 600 and 500 into 500. That's why we are selecting the column is the two types. Then go okay, then okay, column have to be defined. After column have to define and go to the soil subgrade properties. Soil subgrade, after going to the soil subgrade properties, okay, soil subgrade properties, soil subgrade properties. In the soil subgrade properties, in the is the we have to see, we have to show the in display. So soil properties is one of the soil properties, and go to the define and show in the soil properties one, and we are the given the 3 e plus 0.4. So inertial calculation we have to design earlier. So this is the inertial, this is the inertial data, this is the inertial data. So this is the subgrade modulus. Subgrade modulus become from the shape bearing capacity divided by allowable settlement, okay, and this calculation will become obtained that 3 into 10 to the power 4 kilometer cube. This value is the given here, okay, then okay, then okay, okay. After define this is the go to the load pattern. Load pattern is the first we check dead load is the one, like, do nothing to do. Then go to the load case. Load case is the both load case is the linear static, then we have to have not to do. And the go to the load combination. In the load combination, add to the load combination is the load combination. First load combination is the 1.5, and go to the live load is the 1.1.5. okay, this is the for strength purpose. Then okay, then we have one more load combination. This is the one, this is the, this is the dead load, the life load, this is the leave remain is the three option. Then go to okay, then go to okay. So load combination also done, okay. After load combination is defined also be completed. So first we are define the material, then after going to the slab properties, then going to the soil not column properties, and go to the soil upgrade properties. After the load case, in the three type of load cases, load pattern, load case, load combination, this is the three type of load properties we have to be done, then define is completed. Now came to the drawing parts. So how to drawing in the foundation, first we are giving the slab drawing, then going to the column drawing, okay. So first we are go to the slab drawing. So in the slab drawing, select the slab footing, slab, okay. So this, go to the dish, and dish, 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 okay. So slab is complete. Then this is the, this is the column area. So we have a 16 column in the 6 meter spacing in between two column is the spacing between two column is the 6 meters, okay. So we have to increase the 2 meters in the both side, like this side also increase two side, this side also increase two side, upper side also this increase two meters, and both downside means bottom side also increase 2 meters. That's why we're going to edit. First we have to select the area, sorry, select the area, we have to edit, and edit area, and go to the expand and sync area. So we are expand not syncing, that's why. Okay, see, this is the increases, and which is the point value, column value. This is the column, there have a column, there have a column, there have a column. Okay, so we are then drawing to the column. Draw column, then draw column. So first we are going to column below, not below. Column is the none, column is the slab of, in the slab, that's why we are going to the slab one. And this is the 0. Above is, above is 2 meter. Okay, above is 2 meter. Then we are going to the slab, sorry, column. There have a one column, 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 one column, there have a, there have a, like this. Okay, now we are column type 2. There have a one column, there have a one column. Okay, then drawing, column drawing is have done. Then go to the draw design strip. In the draw design strip, so how much we have design strip value we have is the 4.5 meters. It came from the this equation. In this equation it came from the IS code 456 2000. Okay, that's why we are giving the 4. That's why we are giving the 4. And draw this, have to go the there. Okay, then have to discontinue, click the right click, and also have left click. Also have right click, then also left click, so right click, and so left click, right click, also like this. Okay, it's have to be done. It have to be done. Okay, this is also escape. Now we are go to the assign, means we are giving the load. So go to the assign, we go to the first we are go to the select the area, then go to assign, and then the support data and soil properties, and go to the soil properties, then okay, see the soil properties is the came. After go to the, after select the one column, load data, point load, and go to the date load. And this data we have also have data is a dead load is the 1850 and is the 797.6, like as also all data have here. So this data have to be given. Okay, dimension also given, dimension also given, then okay, then also have a one click, then also have a one click, then as same like load data icon, and date is the give is the gone the 5 and 797.6, and dimension also given, then okay, as the as like as same process all column is have to be given. So we have a, before we have a done, that's why we open the file. Sorry, my system is lack. Okay, we are opening the my system. So we have already done, that's why we open the, open is files. Okay, see, sorry, not this, this. See, all the data is the given in the, is going to the column and click the right click, and also dimension have to seen, and load also have to be seen. Okay, like this we have to be check. See, this is the right click and design. Okay, this is the right click. See, this is the dimensions. This is the dimension and this is the load. So as like as is have to be done, then go to the, after giving the load, then go to the run, then run analyze. After run analyze, go to the run analyze and design. So this will be generated. So run analyze have to be done, then go to the display menu and check the value is right or not. See, all the value is the, all there have a, we have a seen the lot of data, and this data have to be less than 1. If is the more less than more than 1, then have to be increase the slab thickness. Like if we are giving the slab thickness 500, then we increase to 1200, 1000, 1200, like this, increase the data for decreasing this value, and this value is the must be less than 1. If is greater than 1, if is more than 1, then it have to be decrease the, it have to be increase the slab thickness. Okay, after this we are displaying the lot of things up there. So I will show is the slab design. Okay, so this is the slab design. Okay, this is the slab design is the x, it is the y direction, this is the x direction. Okay, so we have the one more. This is the slab design is the strip design also have given. This is the shear force, this is the shear force, is the y direction, x direction is the this one the shear force, and movement also have, this is the shear force, and y direction also have, this is the shear force. Okay, and also we have a so crank bar in the top crank bar also have given. This is the crank, this is the slab crank face bottom is the bottom face crack is how much crack, and this is the top face. Okay, and this color is denoted the how to affected in this foundation. Okay, so go to the run and run detailing, then okay, then detailing will also have and go to the display, and it's the all the data have there is the punching here 2D here, default 2D 3D is the slab height, slab thickness, strip force and design force, everything have there. Okay, so this is my project, and I hope you are have to be understand how to design and analyze, and this project is conclude. Thank you.